Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at hot standby router protocol. We'll be discussing an HSRP overview, HSRP Priority and Preemption, and finally, we're going to look at hot standby routing protocol states and timers. This episode is part of my series on switching, routing, and wireless essentials for the Cisco Certified Network Associate, or CCNA for short. I'm Kevin here at KevTechify. Let's get this adventure started. Hot Standby Router Protocol is a Cisco proprietary first hop redundancy protocol. Cisco proprietary, meaning Cisco devices use it. If you have all Cisco system, this is good. For HSRP, there's a IP version 4 version of it, and there's an IP version 6 version of HSRP. It's designed to allow what we call a transparent failover of the first hop IP device. What that means is the transparency is the end user doesn't know this has happened. The end user, all it sees is the default gateway and it goes there. Because that default gateway is virtual and the HSRP is running in the background between several of your devices, at least two, it's deciding which one's the active, which one's the standby, and is doing that communication. And if the active fails, the standby takes over. The end user doesn't know any of that happened because they're all sending to that virtual IP address, that you set as your default gateway. And then the first hop IP device is your default gateway, is that router that connects your network to another network. What HSRP does is it ensures that we have a high network availability, because traditionally operating systems only specify one default gateway. And if that one default gateway, that one IP address goes down, you can't get off of the network normally. If that one IP address is a virtual, and then there's a routing protocol a first hop redundancy protocol that decides which router to use, then that gives us that high network availability. We take a group of routers, and you need at least two, and it goes through an election process, and it selects the active and the standby device. That active device is the one that's routing those packets and sending it back and forth. Standby is just there and it's waiting. It waits and it waits. When it sees the active device went down for whatever reason, it's not sending data anymore, that standby then becomes the active device. That standby device also monitors how that hot standby router protocol, and especially that active device, is doing. That standby is saying, okay, I'm not processing any data, so I have plenty of processor and RAM to monitor how that active router is doing. And then once that decision's made, it says, okay, the active went down, I'm going to take over. And it does it fairly quickly. And like I said, it usually takes a second. The end user, there's a good chance they will never know this has happened, and it happened so quick. They may have to reload in a web page. In the very rare situation where the timing is perfect and everything lined up, they may have to reload in a web page, or something may take a second longer to load in. But for the most part, they're not going to know that you gave the illusion that everything worked fine, even though you had a failure. I hope you're liking this episode on Hot Standby Router Protocol. What are your questions about HSRP? Leave a comment and let me know what your questions are for HSRP. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. The role of the active and standby router is done through the HSRP election process. By default, the election process, the winner is the highest IP address. It's the highest IP address between the devices in this HSRP group of routers. In our diagram here, we have two routers. One router has 172.16.10.2 as its address. The other router is 172.16.10.3. And so we've got 10.2 versus 10.3. If we are going based off the default settings, and it would say router 2 would be the active router. Now, instead of leaving things up to chance and letting it go, let the that election process happen, a lot of people feel it's better to control and understand and basically rig that election so you know which router is going to be the active when that election occurs. And what we can do is we can set the priority. By default, your priority or the router priority is set to 100. They're both set to 100. What you can do is you can go in there and change the priority. You can adjust it higher or lower. If you definitely want R1 in our scenario that has the lower IP address to be the active router, you can go in there and set that priority to 150. If the priorities are even, we default, like I said, we default to the IP version 4 address, whichever one's higher is active. But if you set the priority, the higher priority is that. Now, the command we use to set that is standby priority, and then you put a number in here. That number can be anywhere from 0 to 255. And so you can have different levels of that priority. Now, you do that on the interface. You do that on the interface is where you set your priority. When that election process happens, a router is designated as the active router and the rest of them are designated as standbys. After the election, if you bring another router online or if you change the priority of one of the standby routers to a higher priority than the active router, that first active router after that election will stay the active router until it fails. It will stay as the active router until it fails. But we can say, okay, we want to preempt the election. We want to make a new election happen. And what we have to do is we have to go into the interface, and then from here we can enter in the command on the interface, standby preempt. And what that does is it's going to force the election, and actually there's a double E here. It's going to force the election process to happen, and it's going to go through that, and it's going to say, okay, the highest priority, you are now the active. And once again, if all the priorities are equal, it's going to go to the highest IP address, but it forces that election to happen. With preemption disabled, if you didn't do this standby preempt to force that election process, if you just leave it by itself and preemption is disabled, the router that boots up first with the active router, so whichever router gets the active router role first, they're going to stay that. HSRP, Hot Standby Router Protocol, has several states. The first state here is the initial state. This is the state that's entered in when there's a configuration change or when that interface becomes first available. So when it first comes on or you make a change to it, it comes into that initial state for HSRP. In the learning state, the router hasn't determined what the virtual IP address is. It has yet to hear a hello message from the active router, so it hasn't heard anything. And in this state, the router waits to hear from the active router. And what we're saying here is you have your election process. You went through the group, and now you bring another router online. And then it's in the learning process. It goes from the initial to the learning. Once it learns the virtual IP address, it goes into the listening phase. In this phase, that router, that interface that just came on, is neither the active router or the standby router. So that router is just sort of in limbo. It's listening. It's listening from hello route. It's listening for a hello message from those routers, the active router and the standby router. In the speak state, the router, it sends out a periodic hello message, and it actively participates in election of the active and or the standby router. And finally, when you're in the standby state, that router is a candidate to become the next active router and sends periodic hello messages to make sure that they know it's still available, it's still there, and to also check to make sure that the active router is still functioning. The active and standby routers, they send hello messages to the HSRP group, all the routers in that HSRP group, every 3 seconds by default. So every 3 seconds, it sends out a hello message. And that's the default for it. So every 3 seconds, it sends that out. After 10 seconds, that standby router, if it doesn't get a hello from the active router, what it's going to do is going to assume the active routers went down, and then it's going to go from standby to active. And so to go from standby to active, they have to go 10 seconds. They have to go 10 seconds, basically 3, and then after the third one, start of the fourth one, hellos that they're not getting in a row, the standby becomes that active. Now, these timings, you could raise and lower them. You could change the 3 seconds and the 10 seconds. If you go with smaller increments, if you go down to 1 second and 5 seconds, it'll increase the speed at which failover happens. It'll make that transition from standby to active quicker, but it's also going to increase your CPU usage. It's going to increase that. And a lot of times it may even increase that standby state changes. Because now, after 3 seconds of not hearing a hello after you modified it, it's going to change. And maybe it was just some network congestion where it didn't get through or something like that. But most people say using the default of 3 seconds and 10 seconds, that's a pretty good number to use. It was my pleasure to provide you with this wonderful episode on hot standby router protocol. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials. Once again, I'm Kevin. This here is KevTechify. I'll see you next time for another great adventure.